The study investigates the effectiveness of large language models, LLMs, on the Abstraction and Reasoning Corpus, ARC, dataset, a benchmark for testing abstract reasoning abilities. The ARC dataset requires a fundamental understanding of key concepts such as object identification, basic counting, and elementary geometric principles. The authors convert tasks from the ARC dataset into a prompt-based format for evaluation, initially assessing the model's potential through a zero-shot approach. They then investigate the application of the chain of thought (COT) technique to determine its role in improving model performance. The ARC dataset, created by François Chollet, measures AI's progress towards human-level abstraction and reasoning abilities, resembling Raven's progressive matrices, a traditional IQ test format. The dataset specifies its priors, ensuring it doesn't depend on information outside these defined priors, such as language or other acquired knowledge. The ARC's priors are made similar to core knowledge priors, allowing for a fair comparison between human and artificial intelligence. The study is the first to concentrate on the capabilities of open-source models in this context, providing insights into the limitations of contemporary LLMs in non-linguistic domains, even when dealing with simpler subsets of the ARC dataset. The approaches to solving tasks from the ARC dataset are diverse, encompassing both deep learning and alternative methods. Handcrafted DSLs, grammatical evolution, and object-centric frameworks are highlighted as distinct solutions. The discussion also explores the use of deep learning methods, including the neural abstract reasoner and LLMs like GPT-4. Prompting techniques, such as chain of thought, are emphasized for their importance. Additionally, simpler versions of ARC, like Mini-ARC and Concept ARC, are introduced to better understand the complexity of ARC tasks. The paper examines the performance of large language models, LLMs, on a subset of 50 solvable tasks from the Abstraction and Reasoning Corpus, ARC, dataset. This subset was chosen due to its brevity and simplicity, as these tasks can be solved using a search-based approach. Two prompting techniques were employed: zero-shot, which evaluates the innate ability of LLMs to tackle new challenges, and chain of thought, COT, which guides the models through necessary steps to solve complex tasks. Textual encoding was used to convert the 2D input-output images into a textual format, with each element color in the matrix encoded numerically from 0 to 9. The models tested were Code Llama 7b, Code Llama 13b, Find, and Mixtral. The results showed that the models performed better with the COT prompting method than the zero-shot method. However, even with COT, the models only solved a few tasks successfully. A detailed comparison of the performance of each model using either the zero-shot or COT prompting methods on specific ARC tasks was provided, highlighting that the models achieved success in only a few tasks, with all other tasks resulting in failures. Overall, the study demonstrates the challenges faced by LLMs in solving reasoning-based tasks and emphasizes the need for further research to improve their problem-solving capabilities. The authors present two abstract transformation tasks, 3 and 17, designed to test models' abilities to manipulate input matrices and produce desired output matrices. Task 3 requires shifting non-zero values in each row to the right by one position, filling the leftmost position with a 0 if the row is not all zeros. All models, except Find using the COT method, successfully solved this task. Task 17 involves transforming specific number pairs in the input grid to different number pairs in the output grid. Notably, only Mixtral solved this task using COT. A closer examination of Mixtral's reasoning behind both tasks reveals that, despite producing correct outputs, the underlying reasoning is not always accurate. This highlights the complexity of understanding the thought processes of these models, underscoring the need for further research into their decision-making mechanisms. The results of these tasks demonstrate the model's capabilities and limitations in abstract transformation tasks, emphasizing the importance of continued investigation into their internal workings. Large language models, LLMs, have been evaluated on abstract reasoning tasks, revealing limited effectiveness, with the top-performing model solving only 2 out of 50 tasks. This challenges the assumption that LLMs can readily tackle complex abstract reasoning problems. A comparison of zero-shot and chain of thought, COT, approaches suggests that COT's effectiveness is questionable, as it sometimes yields poorer outcomes. Task-wise analysis reveals that certain tasks are consistently solved across models, indicating easier solvability, while others are rarely or never solved, pointing to their higher complexity. The tasks that are consistently solved may be characterized by their reliance on pattern recognition or simple logical rules, making them more amenable to LLMs. In contrast, tasks that require deeper understanding, abstraction, or creative problem-solving are more challenging for LLMs. This study highlights the significant limitations of LLMs in abstract reasoning, contributing to the growing evidence suggesting that they are a considerable distance from achieving artificial general intelligence, AGI. The findings underscore the need for further research into the development of more effective and robust AI systems capable of abstract reasoning. The study on large language models handling reasoning tasks acknowledges its limitations and potential future directions. The authors recognize that their approach, relying on only two prompting techniques and open-source LLMs, may not be comprehensive. Xu et al.'s 2023 work demonstrated better results with GPT, highlighting the potential for alternative techniques to yield improved outcomes. The focus on the 50 easiest tasks in the Abstraction and Reasoning Corpus, ArC, may not fully capture the complexities of abstract and visual reasoning. Future work could explore various prompting techniques, such as tree of thoughts, TOT, or extensions of chain of thought, COT, to potentially improve the model's ability to tackle a wider range of tasks. Using more advanced models, fine-tuned for abstract reasoning, and evaluating LLMs against simplified versions of the ArC dataset could provide further insights. Comparative studies involving human performance on similar tasks could offer insightful benchmarks for assessing LLMs' capabilities. The study's findings indicate that while LLMs have made remarkable progress in many areas, they are not yet equipped to effectively tackle complex tasks requiring abstract and visual reasoning. The authors encourage further exploration to find innovative ideas and frameworks to enhance the reasoning capabilities of future LLMs. The research paper concludes by summarizing key studies and findings in large language models, starting with the GPT-4 technical report by OpenAI. It then discusses the Llama model, an open and efficient foundation language model designed for accessibility and efficiency. The concept of chain of thought prompting, introduced by Jason Wei et al., is highlighted for its ability to elicit reasoning in large language models. The Abstraction and Reasoning Corpus, ArC, is also mentioned, showcasing successes and failures in abstract reasoning using graphs, constraints, and search.